Okay, thank you, Paul. So look, thank you very much for the opportunity to present here at the 73rd HPC User Forum, and clearly my first. I'm really pleased to be here. It's 3 a.m. in the morning in Perth, so I think I should get some credit for being. I should say and we're looking forward. It's actually 3 a.m. tomorrow in Perth, so I've come back in time to be here with you this afternoon. But I would like to acknowledge the organisers of the forum and the opportunity to participate in an event like this. I'd also like to acknowledge my colleagues at Pawsey who inspire me to through their work and the researchers that we support. I probably should introduce myself a little, as I'm quite new to the HPC community. I've been in the role at Pawsey for just a little over a year. I'm the Executive Director of Pawsey, and it's one of Australia's 2 national Tier 1 centres. This little kangaroo is Paws, is our little mascot, and I will leave that for someone later in the day. So maybe it's for a great question or for something. I'll think of what to do to give that away. I don't come from a traditional HPC background. So it's been a steep learning curve for me in the last 12 months as I learn about the computing side of our business. But I do come with a fairly strong background in working in research, research and industry joint ventures, national programs in certain industries in Australia. And a common theme has been that they've been in complex, multi-stakeholder environments. So far, that seems to be a good complement to the world of HPC. I've led several initiatives that have really focused on accelerating the work of our research nationally and worked across several industry sectors. Most recently, I was the director of an energy and mining institute at the University of Western Australia, and so it's an absolute pleasure to come to a facility, such an important facility such as Argonne. It's almost a bucket list type of opportunity, and several of my colleagues back in Australia are very jealous to say that I'm actually here. And some of the insights last night from Laurel and her talk were very, it was a privilege to hear them firsthand. The importance of connection and collaboration has been a common thread throughout my role in my working life, and I think that's something that I'm bringing to Pawsey, and it will be a bit of a theme in my talk over the next 20 minutes. So within my role, it's the front door at Pawsey. So I have to ask, has anyone been to Perth? Have I missed someone here who has been to Perth? Oh, Steve, you don't count. You do count, you're very special. So most people haven't been to Perth. So we are about 6 or 7 kilometres from the CBD, and that's the front of our facility. Australia is often described as sort of suffering a tyranny of distance, and it will take me about 30 hours to get home in a couple of days. We're an island continent and a long way from mainland Asia, Europe, the Americas and Africa, and we're also a very big island, clearly. I'm fond of telling my colleagues in the United States that Western Australia is 3 times the size of Texas, and we know Texas is a big state. Mainland United States, or the contiguous states, is approximately the same sort of geographic size as the entire Australian continent. But in Australia, we've got about 8% of the population that you have in the United States. I think as a result of that scale and that distance and our geography, we've become quite accustomed at working over distances and overcoming barriers, and so our distributed community is actually quite well connected and quite open to collaboration and engagement. And I think that's something through the Pawsey Centre we're keen to further develop and work on partnerships around the world. So as I mentioned, Pawsey is one of 2 Tier 1 high-performance computing facilities. We're supported by the West Australian Government, the Australian Government, and our joint venture partners, which are the 4 public Western Australian universities and CSIRO, the National Science Organisation. We offer services in supercomputing, large-scale data storage, cloud services, and a visualisation facility that allows the publicly funded research universities and the CSIRO nationally to work through our organisation. Systems are accessed through merit-based research applications, so there's a competitive but merit-based process for our resources. I should have clicked some of those. So you can see in terms of numbers, about 1,900 researchers are supported with over 170 projects. We're about 50 FTE and 50 staff, and an ambitious tagline. We're clearly focused on innovative science that has real impact. Okay. So that's an image of our flagship system, Magnus. It's a Cray system, an XC30, that's now approaching the end of its life. We have two petascale systems, a real-time system that's dedicated to radio astronomy, and that real-time system has a link to a series of telescopes that are 800 kilometres away from Perth, in the middle of the desert. We have a cloud computing service called Nimbus for pilot studies. We offer data analysis workflows in virtual laboratories through Nimbus as well. We have a mid-range cluster for workflows that require larger numbers of smaller jobs, GPU acceleration processors, large memory, data transfers for longer run times, and provide remote visualisation services through those systems. We also have an extensive data store. So our two long-term data storage systems have a combined store of 100 petabytes. And they store research data of national significance and research data sets of national significance, and also a significant amount of radio astronomy data. So about 70 to 80% of our data store is dedicated to radio astronomy. The image, if you can see, just as an aside, the image on the front of the system is of an Indigenous artist's interpretation of the land on which the radio telescopes are operating in the midwest of Western Australia. We also have a fairly unique groundwater cooling system at Pawsey. So we take water out of the aquifers below Pawsey, and through that system we have no net water consumption. We essentially recycle about 21 million litres of water a year, taking it out of the aquifer at 21 degrees and then re-injecting it, I think, 26 to 28 degrees. And that system enables us to be very conservative with our water use. We also have an extensive photovoltaic PV system on our roof, which generates the power and the offsets needed to run that cooling system and to reduce the energy footprint of Pawsey. So I've given you a picture of what we look like now, and we've been operating for almost 2 decades as previously joint ventures within the universities, and then about 6 or 7 years ago an investment to create a national centre in Perth. We received last year a $70 million grant from the Australian Federal Government to begin a capital refresh process to upgrade the facilities that we have in Perth. And so in 2020 our systems will undergo a significant upgrade. The capital refresh program will provide increased computing power and speed, expand our data storage capability, and provide more efficient services to the Australian research community. We've already commenced some aspects of this upgrade, which includes investment in additional tape storage. We have 26 petabytes of tape that's just been upgraded. We've invested in additional high-speed storage for the Murchison Wide Field Array and the Australian Square Kilometre Array Pathfinder project. So these are the two telescopes that are operating in the middle of the desert. And we've commenced a cloud system upgrade, and that procurement is currently out at being evaluated at the moment. We have a compute cluster that's out to market for radio astronomy, and we expect to complete that in the first quarter of 2020. And the major system upgrade for us, we're currently developing the specifications and the requirements and plan to go to market in Q1 2020. So it's a very busy time at Pawsey. This is an image of RayGen, the system at the Canberra National Compute Infrastructure, so the other Tier 1 centre in Australia. They're undergoing a similar capital upgrade, and they're about 12 months ahead of us. So a couple of months ago they announced the successful vendor and are in the process of upgrading RayGen. NCI is also a joint venture that receives Australian government funding, and it's based at the Australian National University. So Pawsey is based at CSIRO, which is a national science organisation, and NCI is managed through the Australian National University. ANU is also joined by the other two other agencies, Geoscience Australia and the Bureau of Meteorology, in forming the NCI Centre. So NCI has a particularly strong focus on climate and geoscience related science, and their system that they've announced is called GADI, which will be 10 times more powerful than the current petaflop system that they're operating. GADI is a nominal word, which is a traditional indigenous word for the traditional owners of the land in which Canberra is located, and it's a word that means to search for. So together, those two centres, you can see Pawsey on the left and NCI on the right, support research nationally across a range of domains. We provide significant international linkage through our research facilities, and we believe we provide an advantage to leading scientists to remain globally competitive through engaging with both of our centres. We're clearly focused on rapidly accelerating the results of their research, particularly in areas that are unable to be projects that are either too big or too fast or too slow to be studied without computational support. We do reduce the costs of research, and an interesting project that Pawsey undertook in the last 6 months was an impact study which quantified the value of HPC and reducing costs, reducing time to market by using computational experimental techniques. That piece of work is also important for us to demonstrate to our major funders the value of investing in HPC infrastructure at scale. The impact study is available if there are any other centres or agencies that are interested in that piece of work. I'm happy to share that with colleagues. It provides 3 or 4 case studies of detailed case studies of research that's supported through Pawsey, and then extrapolates the sort of whole of economy wide benefits that derive from that investment. And the other point to make about the two Tier 1 centres in Perth and in Canberra is that they provide important training grounds to skill and support researchers and those that are working in HPC. And I think I've heard a couple of the speakers today talk about the importance of attracting talent into this industry, and that's an area of importance to Pawsey. So what I'll talk about now is perhaps some of the interesting examples of research that is supported by Pawsey, and we've done this in an array of, I think, interesting partnerships, and some that demonstrate that we do, while we're quite remote, we actually do collaborate and connect into things that are of international significance. So I'm not sure which order these are going to come out, but I'll talk about agriculture first. In agriculture, one of the interesting projects that we support deals with the threat of whiteflies. So whiteflies are pervasive across all continents except Antarctica. And while some of those species are harmless, they're native, some of the others are very damaging to crops, and particularly cassava as an important staple root crop in Africa. So there are very few local tests that can be done to determine whether this is a safe and non-threatening pest, or a pest that needs to be managed. So researchers at the University of Western Australia are actually bringing supercomputing power to support farmers in Africa to collaborate with scientists to determine how to tackle this problem. We're actually sequencing in the field genomes of the whitefly using our cloud services, and then using techniques and supercomputing to genetically distinguish the invasive pests from the native populations in a very quick time frame, in a matter of days. Then the researchers can develop the right sort of tools that they can and systems to work with farmers to actually identify those pests and to mitigate their impact. This sort of research is being able to be applied to farmers from Tanzania right through to Thailand. Another area is of research that we support is in the resources sector, and clearly that's an important part of the Australian economy. About 10 to 15% of the national GDP is driven on the back of the resources sector. It's clearly an important part of what we support in Perth. We also operate in a water-stressed environment, so actually we use significant amounts of groundwater to provide drinking water to the Perth population. With the help of Pawsey, a team from Curtin University has developed very detailed 3D models of the Perth drinking water aquifers, and we use those models and visualise those models to work with government to determine the appropriate extraction sites for water and the management of recharge and the quality of those, the health of those systems over time. In terms of oil and gas, there's a significant amount of investment in offshore infrastructure in Western Australia to support the LNG industry, but designing and predicting how those structures are going to operate in cyclonic conditions. So in the northwest of Western Australia, if you can picture that earlier map of Australia, about a third of the national GDP export GDP is determined in that area, but it also is in a very cyclone-prone environment. So putting in oil and gas infrastructure needs to be put in a way it's designed to deal with cyclones. So we use supercomputing resources to model those structures and determine the most effective locations and structures. And then my last case study to talk about is to do with healthcare, and it's a collaboration that we support with the University of Ontario, Canada, which has partnered with several hospitals to improve real-time healthcare for premature babies. We, using again our Nimbus cloud system, we monitor clinical information and patient vital signs that are continuously monitored, like the heart rate, respiration and blood oxygen, and stream that through a platform called Artemis, which then applies real-time analytics, machine learning, retrospective analysis and data mining to improve nursing care. This particular platform has supported research for sick children in Toronto, Ontario, Providence, Rhode Island, and in Shanghai in China. It can already diagnose different types of neonatal apnea with 98% accuracy, improving the control of their oxygen supply and reducing the risk of permanent eye damage, and can predict infections such as late onset neonatal sepsis. It's one of those applications I think we had presentations on this morning that the impact of AI in this area is very positive. So I think those are some examples of areas that we work on at Pawsey. A major reason we exist at Pawsey is the support for astronomy, and the two images there are from that site that we are directly connected to in Perth, about 800 kilometres north of Perth and about 400 kilometres inland. I was very fortunate about 3 weeks ago to actually travel there. When I was in travel, it was an hour flight and a 4-hour drive, and 3 hours of that drive was on unsealed road in a four-wheel drive. To spend a night in the desert, and trying to explain this, it's in an area that it's ideally set. The West Australian geography is unique. It's in an area that's about 1/3 of the size of the state of Illinois, but it has less than 100 people living in that area. It's a radio quiet zone, so there's no mobile phone connectivity. There's no radio interference, and it's the perfect site to instrument for radio astronomy these telescopes, and there are different types of telescopes. The other point to note about West Australian geography and its advantage for these sorts of projects is it does relate to space and space communications, and the Australian government launched an Australian Space Agency last year, and there's a lot of investment in not just astronomy now, but in ground-to-space communications. Western Australia is one of the only locations in the world that has both NASA and ESA ground stations, and there are dozens of ground-to-space communication facilities because of the, if you like, the quality of our geography and geology, where we sit on the planet, is providing us, we're almost the other side of the planet to Houston and the other side of the planet to Darmstadt. So for both of those agencies, there's reasons to invest in space infrastructure in Western Australia. So I think This is some insight into the infrastructure that's up in the Midwest. So there are two main precursor projects that are being developed in Western Australia for the square kilometre array, and I assume many of you are aware of the SKA project. It's really a global mega science project with over 100 organisations and 20 countries that are working together to build an array of telescopes that will enable them to explore the origins of our universe in unprecedented detail. So in the desert there are telescopes, there's a supercomputing facility in the desert that, with correlators, that take this data and then stream it down to a dedicated facility at Pawsey. The area, this project, is really illustrating one of the, I think, the largest examples of global science collaboration with HPC, I think, on the planet. There's significant opportunities that leverage from this in terms of our understanding and our ability to manage the data flows and the data volumes that are unprecedented when this project is operating at full scale. It is currently in precursor stage, and so they're talking about within this decade, the turning on of this system will generate in its first day more data flows than exist on the current state of the internet, that the computing infrastructure is not there yet to be able to manage this, and the data store challenges and data processing challenges are yet to be resolved. So the science challenges are amazing, but the business, industry and government benefits that can flow from our scientists and our engineers solving these problems are tremendous. One point I'd like to make about that is to really emphasise, I think this is a theme from some of this morning about the changing nature of science. I think I mentioned this SKA as a global science project. It really is an illustration of some of the future challenges facing HPC, which is increasingly data intensive. It will generate enormous amounts of data and require immense computing power to produce the data products for the scientists that will enable them to do their research. But this sort of tidal wave of data threatens to overwhelm us, and it's consuming our attention by its volume and diversity. And we're in a sense moving to sort of a state of data deluge. But this data deluge is changing the fundamentals of our scientific approach, from the traditional hypothesis-driven scientific method to science based on exploration. So the researchers that we are working with no longer ask, what sort of experiment could I construct to test this hypothesis? They increasingly ask, what sort of conclusions can I draw from all of this data? Or what insights could I receive or gain if I combine data from different disciplines and domains? So I think, as I think we got some insight from Rick's presentation this morning, I think it's an exciting time for researchers and supercomputing and artificial intelligence and machine learning that are at the front and centre of this new wave of development. There is a challenge to analyse petabytes of data on a timescale that is practical in human terms and ensure that there is a strategy around that data. I think data itself does not have intrinsic value without the analytic filter that points to discovery. And the collaboration between science and industry, between data harvesting and value creation, is quite critical. So I think there's an opportunity for the HPC community to support this collaboration, this relationship. And the nature of science and the multidisciplinary complexity of the world's problems means that our engagement with other researchers and infrastructure providers, government and industry, will continue to grow, as will our partnerships in HPC. So I believe, and I'm excited by my first year in this area, that supercomputing plays a pivotal role in data-enabled problem solving. As we use our technologies in a more of a wider, connected way, we can help to deliver better, faster and more innovative scientific solutions that not just benefit our own local community, but can benefit the global community. So I think to achieve that, we can't just focus on the hardware and the software. We also need to work on engagement, collaboration and diversity. And at Pawsey we focus a considerable amount of our effort on developing the talent pool that supports the work that we do. We invest in the development of the next generation of data scientists working through our universities and CSIRO. We work in training our end users and try to bring that community together at some scale. So we run various on-site training programs, hackathons, career evenings, roadshows, user forums across the country. We also have an intern program, so we're a small centre, but we still have 14 or 15 interns that join us each summer to work on student-sponsored projects in an immersive 10-week program. I think we've still got a fair way to go. I'm a little embarrassed to say that 10% of the people at Pawsey are actually called Mark. Now, Mark's a good name. I'm not going to, and I'm counting Marco from Italy as an honorary Mark in that breakdown. But it does illustrate the challenge that we have to encourage diversity and new talent into our area. I think we do need to grow and diversify our talent base within Australia, and we're working to do that. And that's one of the reasons why engaging in a forum such as this and in areas where there's significant critical mass in Europe and in the United States around HPC is something that we're keen to support and engage in from Australia. Now, as I close, I see a minute to go. I think at the start of my presentation I introduced you to Pawsey Kangaroo. Now I'm going to introduce you to this one. And there's a quick question. Does anyone know what this one is? It's not to scale. I'll give you a clue. To scale, the big ones that you see in the desert are as big as me. And I'm 6'4". The big one, there'll be 6'4", 6'5". The tallest kangaroos reached almost, I think, 2.1 metres. And then they can stand up on their back tails and get very tall, so 7, 8 feet. This one is about a foot tall. So we have a scale problem. So if I did that, no. Okay, no one knows what this one is. Sorry? Wallaby? No, it's not a wallaby. No good. Steve, help us out. If I said Steve, Rottnest Island. Okay. We've got to work on our marketing here. This hasn't been launched yet. It's actually a quokka. So it's a quokka. It's native to a small island off Western Australia, so Rottnest Island. So it's a quokka, but it's becoming quite popular with celebrities that come to visit Perth. So there you go. They're very cute little animals that smile when they get close to the camera. So everyone can recognise the god of thunder, Thor, I should imagine. But there's a lot of effort to market West Australia as a fantastic place to visit. So the next Pawsey mascot is actually a quokka, and we'll release this in the next month or so. We'll have them available at SC, so Supercomputing, where several of my colleagues will be, and we'd love to, many of you will be at SC in November in Denver, and we welcome you to adopt a quokka to take home. We won't have any more kangaroos, I don't think, so I'm hoping that someone from the lab might like to adopt a kangaroo. But I would like to thank you for giving me the opportunity again to speak today, to join this forum and to hopefully contribute as positively as we can on behalf of both the centres in Australia, the chance to support this wonderful industry that we're in. Thank you very much.
Where's New Zealand in all of this?
No, it's like an extra state of Australia. So we're very close with our colleagues in New Zealand, and it's probably remiss of me not to have acknowledged them. So Nessie, there are regular engagements and across the three centres. So it's a much smaller facility than the two centres in Australia. But with respect to the Square Kilometre Array project, actually New Zealand has just withdrawn from that project, so their focus is a little different. But in terms of regional events, in sort of Asia-Pacific events, New Zealand were active collaborators and work closely with. But I don't know the analogy in America, but there's strong competition between us on the sporting field. So rugby, cricket, those sorts of things, we compete very, very, very seriously in. But we do collaborate well in this area.
So you talked about Pawsey and NCI. I know there was some recent also funding from the RSC and Center and so on. So talk about the role of clouds through Nectar going forward in Australia, as well as maybe the data management issues. And if anybody needs answers to Nessie, I can give you an update on Nessie. So
ARDC, the investment, so I said $70 million went into upgrading Pawsey, $70 million has gone into upgrading NCI. The Australian government invested $70 million to establish a new vehicle for investing in cloud-supported data storage for the national research community. It's still very new. It's only become an incorporated, it's a different model. It's a company, and it's working through its investment model with research organisations as we speak, and it's only running some small pilot investments at the moment. So it's still very new. We're still working out how each of the two national Tier 1 centres can partner with the ARDC, because it's seeking to invest and then get a return from each of the sort of universities about making available that resource. So a work in progress and new space. Pawsey feels less exposed to that because we invest quite heavily in our data storage capability because of our dedicated support for the radio astronomy community. NCI has perhaps more exposure to that model of where is the funding and the support for data storage going to come from.